Assalamu alaikum wa rahmatullahi wa barakatuh, my dear students. Hope you people are at the peak of your health conditions by the grace and the clemency of Almighty Allah. Last time we were talking about some of the important postulates of the Dalton's atomic theory. As far as this Dalton's atomic theory is concerned, it was actually proposed by Dalton in 1808 after the laws of chemical combination, like law of conservation of mass and the law of definite proportions. My dear students, we discussed those laws, and after that we in the last video lecture we discussed some of the important postulates as far as this Dalton's atomic theory is concerned. Let me recapitulate first what we discussed in the last video lecture, my dear students. We discussed postulate number 4. According to the postulate number 4, all the atoms of a given element are identical in all respects, having the same mass, size, and the chemical properties. For example, I gave you the example of a potassium. I told you people, the moment we will break this potassium is actually the element of the periodic table, having atomic number 19. As far as this potassium is concerned, the moment we will break this potassium, ultimately this potassium will get changed into millions and the trillions of the atoms, millions and trillions of the tiny, indivisible, rather indestructible ultimate particles. We call those indestructible, I mean to say tiny indivisible particles, as atoms. So I told you people that the moment we will break this potassium will get changed into millions and trillions of the atoms. What actually Dalton said, he said that the moment we will break this element, all the atoms, the moment it will get changed into the atoms, every single atom of this potassium will show identical properties. I mean say all the atoms are identical in all respects. That means in the respect of mass, in respect of size, and in respect of chemical properties. That means all the atoms will have the same mass, they will have the same size, my dear students, and they will show the same chemical behavior. I mean say same chemical properties, my dear students. That was the fourth postulate. So fourth postulate was all the atoms of a given element are identical in all respects, having the same mass, size, and the chemical properties. This was the fourth postulate. And regarding the fifth postulate, I told you people atoms of different elements. I gave you the example of, I can say, sodium and rubidium. I told you people that the sodium and rubidium are the two different elements, and these two elements will show different physical properties. They will show different, I can say, these elements, these two elements like sodium and potassium will show different properties. That means the atoms of different elements, these are the atoms of different elements, are different, and they will have different mass, they will have different size, and they will have different chemical properties. So the fifth postulate, my dear students, was atoms of different elements, or I can say different and have different masses, they have different size, and they will show the different chemical properties. This was the I can say the recapitulation of the last video lecture, what we discussed, I mean to say, in the last video. So today we are going to discuss some more postulates regarding this Dalton's atomic theory. Let's discuss these some more postulates, I mean to say, my dear students, regarding this Dalton's atomic theory. So today we are going to discuss postulate number 6 of Dalton's atomic theory. I told you people that this is actually this Dalton's atomic theory revolving the, I can say, atom. The, I can say, nitty-gritty of this Dalton's atomic theory is to understand actually the basic concept of atom, what actually this atom is. So the sixth postulate of Dalton's atomic theory is atoms combine with each other in small whole numbers, my dear students. What does this postulate actually mean? This means during a chemical combination, whenever I talk about chemical combination, mark my words, my dear student, and jot it down. Chemical combination. Chemical combination, I mean to say, whenever there is a chemical reaction, that means this is chemical combination. During chemical combination, atoms of different elements combine in simple whole number ratios to form compounds. What does this statement actually mean? This postulate, postulate number 6, is actually in accordance with law of definite proportions, my dear students. Somebody will pose you a question that which postulate, and this has been asked so many times in the competitive examinations, my dear students, that somebody will pose you a question that which postulate of the Dalton's atomic theory actually resembles with the I mean to say the law of definite proportions. You people should answer at that very time in a jiffy that postulate number 6. Postulate number 6 is actually atoms combine with each other in small whole numbers to form compounds, actually to form compounds, my dear students. Mark my words. So the sixth postulate is during a chemical combination, atoms of different elements combine in simple whole number ratios to form compounds. That means they combine in simple whole number ratios to form compounds. So the basic nitty-gritty, the bottom line of the chemical combination is to form the compounds. That means when atoms, or I can say different atoms, combine with each other, they form the compounds. And I have given you almost 2 to 3 lectures on these compounds. So as far as this sixth postulate is concerned, during a chemical combination, atoms of different elements combine in simple whole number ratios to form compounds. That means this postulate number 6 is in accordance with the law of definite proportions. So what the law of definite proportions is, we have discussed briefly this law of definite proportions, but I mean to say there is a need that I should recapitulate what actually this law of definite proportions is. According to the law of definite proportions, in a pure chemical substance, the elements are always present in definite proportions by mass. That means whatever may be the source from which a compound is obtained, it's always made up of the same elements in the same proportion by mass, my dear students. For example, let's discuss example of this postulate number 6. As far as this law of definite, I told you people that this postulate is in accordance with the law of definite proportions. So according to law of definite proportions, in a pure chemical substance, the elements are always present in fixed proportions by mass. What does this mean actually? For example, let's consider the example of, I have given you the example of the water in that very lecture, I mean to say. Let me recapitulate that very example to make you people understand what actually this postulate number 6 is. According to this postulate number 6, during a chemical combination, atoms of different elements combine in simple whole number ratios to form compounds. You might have gone through these whole numbers. Whole numbers are actually the numbers which start from the 0. Same is the case with this. So it's a for example, let's consider the example of a water. Let's consider the example of a water. This is water. Formula of a water. It is actually a compound of hydrogen and oxygen. Whenever there is a formation of a water, it's a chemical combination of, so sixth postulate, during a chemical combination. That means during a chemical combination of hydrogen and oxygen, there is always the formation of a water, my dear students. So if I can say the ratio between these is always 1:8. This is a simple whole number ratio. 1:8. Whatever may be the source from which a compound is obtained. It's a compound the ratio will always remain same. That means it's always made up of the same elements in the same proportion by mass. For example, whatever may be the source doesn't, I can say, so whenever I talk about the source, a source maybe, I can say, pond, source may be well, source may be river, source may be sea, etc. So it's always made up of the same elements in the same proportion by mass. This means that whatever may be the source from which a compound is obtained, it's always made up of the same elements in the same proportion by mass. That's why I told you people that sixth postulate: during a chemical combination, atoms of different elements combine in a simple whole number ratio to form compounds. Simple whole number ratio, this 1:8, this simple whole number ratio 1:8. One part of hydrogen reacts with 8 parts of the oxygen, then water molecule get formed. The same is the case with this. Whenever there is a formation of a carbon dioxide, this is carbon dioxide, the ratio remains always 3:8. That means 3 parts of carbon and 8 parts of oxygen. That's why the sixth postulate is telling us that during a chemical combination, there's a chemical combination, that means reaction of carbon plus oxygen always gets carbon dioxide gets formed. It's a chemical combination. That means I can say the reaction of carbon and oxygen during their chemical combination, atoms of different elements, this one element, this another element, atoms of different elements combine in a simple whole number ratio, that's 3:8 ratio, to form the compounds, and the compound carbon dioxide gets formed. This is actually the postulate number 6, and this postulate number 6 is in accordance with the law of definite proportions. So hope you people have enjoyed this. In next video lecture, we are going to discuss one more postulate regarding this Dalton's atomic theory. Till then, Allah Hafiz, stay safe and stay at your homes. May Almighty Allah put you in cloud 9, and thanks for watching this.